Welcome to today's explainer. I am incredibly excited to guide you through this one because we're looking at a massive paradigm shift in artificial intelligence today, coming straight out of Google Cloud. Now, if you've spent any time at all working with generative AI, you already know that keeping these systems truly context-aware over a long period of time is, well, it's basically one of the hardest challenges in the entire field. But today, we're going to look at a reference implementation that completely flips the script on how AI systems remember. So get comfortable and let's explore Google Cloud's always-on memory agent. To understand why this new architecture is so groundbreaking, we first have to ask a frustratingly common question. Why do AI agents always forget? It's that classic AI amnesia problem. You know the feeling. You have a brilliant, deep, highly nuanced interaction with a model. But the moment that specific session ends or your context window maxes out, poof, it's just gone.
The standard state of play right now is highly transactional. Most AI agents process a request, they give you an answer, and then they immediately drop the context. They're essentially stateless. So you're constantly forced to remind the AI of past interactions or re-upload your documents or engineer these crazy complex prompts just to get it back up to speed. But Google Cloud's generative AI repository recently shipped a sample that tackles this amnesia directly, and it takes a wildly different approach than you might expect.
Which brings us to our first main topic. Meet the always-on agent. Okay, let's dive into this. The always-on memory agent is fundamentally a lightweight background agent that just never stops. We're talking about a structural pivot in how artificial intelligence handles context over time. It runs 24/7 as a continuous process. It's not a one-shot API call that spins up, answers, and immediately dies. Built using the Google Agent Development Kit, or ADK, and powered by the highly efficient Gemini 3.1 flashlight model, this agent treats memory as an ongoing living process. And here's a totally surprising structural choice. Get this: no vector database, no embeddings. Instead, it relies on structured memory in SQLite. The large language model literally reads, thinks, and writes directly into standard relational rows in an SQLite database. By choosing Gemini 3.1 Flashlight and SQLite, Google is specifically targeting incredibly low latency and low compute cost. And that is exactly what you need if an agent is going to be doing continuous background work around the clock.
Let's move on to how it operates. Ingest, consolidate, query. So how exactly does it pull this off without embeddings? Well, the entire system is managed by an orchestrator that routes every single incoming request to one of three specialist subagents. First up, the ingest agent takes incoming content, uses Gemini's multimodal capabilities to extract a summary, entities, topics, and an importance score, and then drops that structured record into a memories table. After that, the consolidate agent synthesizes the data, and finally, the query agent actually answers your questions by reading all those memories and consolidated insights to generate a response. And importantly, it cites the exact memory IDs it used as sources. Each of these subagents owns its very own specific tools for reading or writing to the memory store.
But the true magic of this architecture really lies in step 2, the consolidate agent. Look at this brilliant human brain analogy from the source material. Like sleep cycles, it reviews unconsolidated memories and finds connections between them. By default, this actually runs on a timer every 30 minutes. The agent wakes up, looks at the new information it gathered, connects the dots, and writes a synthesized summary and key insights back into the database. It's building brand new understanding while completely idle without you ever even giving it a prompt.
So what exactly can the ingest agent process? An impressive 27 different file types. And the ingestion process is entirely automatic. You literally just drop the file into a designated inbox folder, and the agent picks it up.
Let's quickly break down those 27 file types across these 5 categories. Because this uses Gemini 3.1 Flashlight, it is wildly multimodal. It's not just absorbing standard text files like CSVs or Markdown. It takes in images, audio files like MP3s or WAVs, full video files like MP4s, and of course your standard PDFs. You can toss a meeting recording, a screenshot of a confusing chart, and a super dense PDF report into the inbox folder, and the agent will ingest all of them, extract the entities, and later, during its sleep cycle, actually find the connections between the audio, the image, and the text.
Next up, leaving RAG behind. Now, what's really interesting about this is how it stacks up against current industry mainstays. Think about vector databases in RAG, Retrieval-Augmented Generation. It stores embeddings, sure, but it has zero active processing. It's totally passive. It embeds once and just waits. Conversation summaries compress text, but they inevitably lose granular detail, and they can't cross-reference well.
Knowledge graphs use nodes and edges, but they require massive manual upkeep, making them really expensive to build and maintain. But then consider the always-on memory agent. It uses structured SQLite rows and performs continuous consolidation. The only real limitation noted right now is a query read limit of up to 50 recent memories at a time.
Let's explicitly contrast the two major players here. RAG relies on passive retrieval. It just sits there, holding your embedded data, doing absolutely nothing until you specifically ask it a question. The always-on agent, on the other hand, is active continuous processing. It doesn't wait for your prompt. It is actively working in the background 24/7, linking related memories and writing entirely new insights while idle. It's basically the difference between a static filing cabinet and an active research assistant working overtime.
So let's look at some real-world use cases.
What does this active continuous processing look like in practice? Well, these three examples perfectly illustrate the power of evolving context. Imagine using this as a research assistant. You feed it PDFs, meeting audio, and screenshots all week long. Over the weekend, without you even asking, it links a cost target mentioned in a PDF to a reliability problem discussed in an audio file. Or use it as a personal knowledge base, absorbing your notes and articles, eventually surfacing high-level themes you never consciously realized were connected. Or even a support agent that automatically stores past tickets as structured memories and then tackles new cases by independently citing references and solutions from tickets closed months ago.
All right, let's wrap up with getting started today.
You might be thinking a system like this requires some massive, complicated deployment, but for early-level engineers, the setup is incredibly minimal. And this brilliantly illustrates just how accessible it is. Install your Python dependencies, export your Google Gemini API key into your environment, and run the Python script. That is literally it. With just those 3 steps, the agent is alive. It immediately starts watching the inbox folder, sets up its 30-minute consolidation timer, and spins up an HTTP API running right on port 8888.
Because it exposes an HTTP API, you can easily feed it data via POST requests or curl commands, which makes it highly integratable into your existing software. Plus, you have complete control. Using simple command line interface flags, you can easily tweak the watch folder location, change the port, or adjust the consolidation interval if you want it to sleep more or less frequently. There's even an optional Streamlit dashboard you can launch that gives you this beautiful user-friendly interface for ingestion, querying, and just browsing what the agent is currently thinking about.
We've covered a lot of ground today, from the limitations of passive RAG to the immense potential of structured SQLite memory powered by Gemini 3.1 Flashlight. But I want to leave you with this final, visionary thought. The entire paradigm here is built on that sleep cycle metaphor. By shifting from a system that only thinks when prompted to a continuous 24/7 process, we're unlocking a whole new level of machine utility. If your AI is constantly connecting the dots, synthesizing data, and building new understanding while idle, what insights will it have discovered by the time you wake up tomorrow morning? Thank you so much for joining me for this explainer, and I highly encourage you to go try out the always-on memory agent for yourself.